As we shift gears from the alimentary canal to the accessory organs, let's first go through the whole entire alimentary canal one more time, and then look at the accessory organs from that point onwards. So remember, we start in the alimentary canal with the mouth, the ingestion. From there, you're heading back into the pharynx, back of your throat. Heading down into the esophagus next. Esophagus goes into the stomach. From the stomach, you're heading into the three regions of the small intestines: the duodenum, the jejunum, and the ileum. And again, watch that spelling, I-L-E-U-M, E for eating. Then you go into the large intestines, which you start with the cecum. That's the very beginning portion of it. Then up the ascending colon. Then going across the transverse colon. You're going down the descending colon, heading into the sigmoid colon, and eventually down into the rectum and anal canal. All right, alimentary canal, mouth through anus. That is where the food and all the breakdown and waste is passing through. All right, accessory organs. Now this is what we're moving into. These are the things that help out with digestion. Food does not pass through them, or at least naturally it shouldn't pass through them, but they're still going to help out with the digestive process. We have the tongue. Sure, moves the food around the mouth. We have the salivary glands, secreting saliva. We're going to have the liver, which we'll get to in a second. We're going to have the gallbladder. Also, we'll talk about that briefly in a second. We have the spleen. We have the pancreas. And we even have the appendix a little bit down there. So all different accessory organs that are meant to help out. Not food going through, but helping out the digestive process. So let's start with the liver. Now this is an actual picture of a liver. What you're seeing here so far is you can notice the gallbladder is sitting right down there. This is an anterior view looking at the front here. So you're only seeing a portion of the gallbladder. And we'll discuss the gallbladder more later. Just want to be aware that's the location here next to the liver. You're going to have your right and left lobes. Your right lobe, obviously the right side of your body, left lobe on the left side. You're going to have the falciform ligament. That's this line right in the middle here. And then you have the round ligament going off just below it. Moving into the posterior view, so looking from behind now. Looking again, you can still see the gallbladder right there. We'll get to the gallbladder and its functions later on, but just be aware of the location right next to the liver. But from this posterior view now, we're going to be able to see all four of the lobes of the liver. Sure, we still have the right and left lobe, but now we have the caudate lobe. That's right up here. We also have the quadrate lobe, which is right down here. So there's four lobes in total that you can see from the posterior side. You still have that ligamentum teres. Now this is a view that's more of an artist's rendition. It's easier to see the ducts of the liver in this view than it was in the previous two. Now, can you see them in the actual true livers? Sure, but it's just easier this way. It's better for learning so you can see very clearly what you're looking at. So start off, we're going to have the right and left hepatic ducts. That's this piece over here and this piece over here. Once they join together, the base that comes off of that is called the common hepatic duct. Now the common hepatic duct isn't very large, only this little section right there. Because once you have a branching meet again, then it changes name. So the common hepatic duct comes down, it meets with a branch coming in. That branch is the cystic duct coming from the gallbladder. Now, beyond that, from here downwards, we have a new name for this one because now it's two combining. That is the bile duct. And there's the bile sphincter at the very end, helps control the flow of fluid. But all that is going right into this major duodenal papilla, that structure we talked about before with the small intestines. So a couple of the ducts we're looking at from the liver. From the right and left hepatic ducts, going down to the common hepatic duct, which joins the cystic duct, and eventually goes into the bile duct and the small intestines. So what are we looking at from a microscopic view? What do we see in the liver? Well, we have these individual liver lobules, these hexagonal structures. And they're literally making stacks, just stacks of these hexagonal structures. I'll show you a picture in a second, but for now, just think about pancakes. If you make a stack of pancakes, each pancake would be an individual liver lobule. And right through the middle would be a straw, that would be a vein. So look at that in 1 second though. But their main purpose, filter and process the nutrient-rich blood. We've talked about the hepatic portal system, how it collects all that blood from the entire GI tract and brings it up for filtering. There's tons of nutrients in there that you just absorbed. So that's this nutrient-rich process. Now these liver cells, these hepatocytes, are what do all the processing. They're not only processing the nutrients, but they're filtering out any bacteria, any waste, any broken down components, anything that shouldn't be there. So it's serving both the process of getting the good out and getting the bad out. More like detoxifying, if you think about it that way. There is a longitudinal central vein. That was what I was just talking about, that straw inside of the pancakes. That runs through the middle of every one of these hepatocytes. So we have a plentiful amount of blood flow going into these for filtration. So looking here, this is one single lobule. You can see in the other view, we have a whole bunch of these all set together. It's kind of a nice symmetrical view of all of these lobules stacked and maximizing space. So here we're looking at an artist's rendition. Now this is a little easier to see more of a three-dimensional view of this entire hepatocyte and the stack of lobules. So what we're looking at here, first off, is this portal triad. The portal triad, you see red, blue, and green. The blue are going to be venules. The red are going to be arterioles. The green is the bile ducts. So that's the movement of bile. So you can see there are plenty of these different structures all completely around the entire structure. That means there's plenty of blood flow going in, plenty of blood flow coming out, as well as plenty of collection of bile. Now if you notice, those bile ducts are coming from these bile canaliculi. Those are going out and towards the bile duct. So it's bringing bile out because the liver is producing bile. We then have the hepatic macrophages. They're simply just going throughout all these vessels. The idea is they're trying to make sure they're cleaning out any bacteria, any debris, anything that shouldn't be there. You have the sinusoids, plenty of flow, plenty of fluid movement through there. They're fenestrated, so everything's going in and out very easily. You can see the central vein right in the middle up here. That's the central vein going right through the entire lobule. So it's creating plenty of blood flow being collected. So coming in from the outside, and they're going up through the middle, heading back towards these interlobular veins and towards these hepatic veins. They're trying to basically leave the liver because it's cleaned out. It's filtered out at that point. So a little bit about the histological structure of the liver so far. So we've said that it's processing nutrients. Nothing new there. Fat-soluble vitamins are being aided here. So what's happening is you can actually store them in the liver because the liver has a component, fat components. So it's storing the fat-soluble vitamins for when you need them later on, after a meal or whenever you need to pull them out. It can perform detoxification. Now, I mentioned detoxification before. Basically, you're ingesting things. They're not perfectly clean. So therefore, there sometimes are problems. Plasma protein synthesis. Well, you're making these plasma proteins that are needed and used throughout the entire body here. Metabolic regulation. Well, you have all these nutrients coming in. You've got to help with metabolism here. Metabolism is working. And then finally, about 900 milliliters of bile per day. If your gallbladder is intact, you're not secreting 900 milliliters of bile into your intestines. The gallbladder concentrates it. But if your gallbladder is removed, those 900 milliliters are slowly heading into your intestines throughout the day. So what is bile? Well, bile is going to be very important in the processing of fats. What happens is it deals with fat emulsification. Now that's not saying you're going to break down the lipids into their base components. Emulsification is taking a large chunk of fat or lipid and breaking it into smaller chunks of lipids. Kind of think of it this way. You have a stick of butter. If you're trying to digest that stick of butter, you can only work on the outside surfaces. But now take that stick of butter and cut it up into a whole bunch of pieces. You've increased the surface area, so therefore you've increased the ability for the enzymes to come in and break down that stick of butter. That's what emulsification is doing. It's taking a large chunk and then breaking it into smaller chunks, allowing a better surface area for more enzymes to actually work and do their job. So that's helping the bile salts inside the bile there. Otherwise, bilirubin's here as well in there. Bilirubin, hopefully that rings a bell back from the blood chapter, because bilirubin comes from the heme portion of hemoglobin. So as you break down and recycle, bilirubin's a byproduct of recycling. Then you have cholesterol, neutral fats, phospholipids, electrolytes. All of these are components of bile that allow it to get in close and work with the lipids you've ingested. So bile really is a necessary product to help with your lipid digestion. It's not a chemical breakdown because it's not an enzyme. This is physically just separating the lipids into smaller pieces. Now, as far as the circulation goes, you recycle the bile salts. So they go into your small intestines at the duodenum, but then you're going to reabsorb them and pull them back out. You want to try to reabsorb as much of them out of the ileum as possible. What goes then into the hepatic portal blood and then back up to the liver. Once it gets back in the liver, they're stored until used again to make more bile. There's a constant process of you trying to reuse and reclaim as much as possible. You don't want to waste them if you can help it. So a little bit about the liver, looking at some functionality and bile production.